So for today, I'm going to be working questions 25 and 26. It says prove or disprove. Okay, so we have to work something out. We have to show stuff. Okay, prove or disprove that the point 16.6 is on the circle with center 6.6 that passes through the point 16.10. Okay, so this is what this thing is telling me. That I have a center, I have a circle, and the center of my circle, let me point it out, is 6.6. Right? I can draw it. I can get my coordinate plane. I can plug in the point 6.6. And then there is a point 1630, right? That's a point that is on the circle. I can grab my compass. I can plot my centered. I can plot the point on the circle, and I can just draw a circle. So the point 1630 tells me how much to open the compass. I can draw the circle. And then it's asking me to check, is the point 16.6 on the circle or not? So it says prove or disprove that the point is on the circle, right? Prove if it is or disprove if it's not. So this is one thing I'm gonna do. First of all, I'm gonna find out because I know the distance between the centered and any point on the circle is basically the radius, right? And the radius is the same. So that's the distance between the centered and any point on the circle should be the same thing. So this is what I'm going to do. Let me find the distance between the centered and a point that I know it's on the circle. So basically, I have the point 6.6 because that's the center of the circle and the point 1630. Let me find out what's the distance between those 2 points. Okay, so let's take a look. I remembered the distance formula. We talked about this already. Let me write it up here so we don't forget it. The distance, I'm going to write D for distance. First, I subtract the y. So the second y minus the first y all squared plus, and then I subtract the x's. The second x minus the first x all squared. And this is then is inside a square root. Okay, so having that said, let's see. So remember, I have the centered and the point 1630. So I'm going to subtract the y's. And remember, I already talked about a secret. The order, I could go 30 minus 6 or 6 minus 30. In reality, the order doesn't really matter. The difference is going to be a sign, right? My answer is positive or my answer is negative. But because I'm going to square the answer, I'm going to get rid of the negative. So honestly, what I'm going to do, I'm going to start with the bigger number. So looking at the y values only, let me go 30 minus 6. I'm going to start with the bigger number, so I'm going to avoid the negative sign. Right? If I get a negative sign, I'm going to square it, and then the negative sign is going to go away anyways. And then I'm going to subtract the x's. I see 16 and 6. So I'm going to go 16 minus 6, all squared. So this basically is, okay, 30 minus 6, that's 24, right? 24 squared. 16 minus 6, that's 10 squared. I'm gonna type it in my calculator. You guys have a calculator. I'm not gonna show how to do it. I think I've shown you guys enough. I'm just gonna type it in. Square root of 24 squared plus 10 squared. And this thing tells me 26. Okay, the radius is 26. I just found that out. Good. Now, what I'm going to do is I'm gonna use the center of the circle and the other point. Okay, the center of the circle and the other point. The center of the circle is 6.6. The other point is 16.6. Let me find that distance. So again, I'm looking at the difference, the distance between the point 6.6 and the point 16.6. So first, let me subtract the y's. 6 minus 6 all square. Now let me subtract the x's. 16 minus 6 all square. Okay, for the first point, it's 6 minus 6, that's 0. So 0 squared. 16 minus 6, that's 10. 10 squared. And if I type this on my calculator, I'm going to get, so the square root of 0 squared plus 10 squared, it gives me 10. So remember how I said that when I started this question, I said, let me find the distance from the center to a point on the circle, and I did that on red. The radius is 26. Now let me find the distance between the center and the other point, and the distance is 10. The distance is not the radius, right? The distance are different. So is the point on the circle? In this case, I'm going to say no. No, it's not on the circle because the distance between the center and this other point is not equal to the radius. Okay, let's do this other question here. Let me take a look at here. Prove or disprove that the point -3, -6 is on the circle with the center, it is 5, 9, that passes through the point 13, 24. So let me find out what's the length of the radius. I'm going to use the centered and the point that is on the circle. So I'm going to find the distance between those 2 points. So I'm basically looking at the point 5, 9 and the point 13, 24. Okay, I want to find this distance. I wrote my coordinates there so I remember which points I'm looking at. So I have to subtract the y's first, right? So I'm going to go 24 minus 9 all squared plus. Then I have to subtract the x's, 13 minus 5 all squared, and this is inside the square root. Okay, 24 minus 9 is 15. So I have 15 squared. 13 minus 5 is 8. So I have 8 squared. I type this on my calculator, the square root of 15 squared plus 8 squared, and my calculator says 17. So the radius is 17. Okay. Now let me find the distance between the centered and the other point. If my distance is equal to 17, which is the radius, then the point is on the circle. If my distance is not 17, then the point is not on the circle. So again, I'm looking at the distance between the points 5, 9 and -3, -6. I write my coordinates just so I remembered which points I'm dealing with. And I'm doing it blue so you guys can see the difference. So first I have to subtract the y's. So I'm gonna go 9 minus a -6. Remember, I start with the bigger number, try to avoid negative signs if possible. Then I have to subtract the x's, right? So 5 minus a -3. And all this is inside a square root. Looking at my first parentheses, the 2 negative signs become a plus sign. So 9 plus 6 is 15. So 15 squared. Here, 2 negative signs become a plus sign. 5 plus 3 is 8. So the square root of 15 squared plus 8 squared happens to give me 17. Oh, the distances are the same. Okay, so is the point on the circle? In this case, yes.